Hello, everyone.
So just start.
Okay. Yeah, I'm Charlie Su from Andes Technology. I'm president and CTO. Okay, now I hear myself. So we saw a very interesting demonstration from chip aging. So my part is mostly talk, but at the end I'm going to have some short demo. Okay. So I'm going to talk about how Andes solutions to accelerate AI and machine learning. Okay, so for those who don't know Andes, Andes is a pure-play CPU IP vendor for over 20 years. We went public in 2017, and we have been leading RISC-V IP market share since 2023, according to the market research group, SHD. And we are active in RISC-V community, RVI and RISE. And some quick number, we offer a lot of RISC-V processor IP. And we have over 16 billion processor shipped by our customers, SoC. Whoops. So our product has been going to a lot of end product there, from endpoints, edge to cloud, like Wi-Fi 7 and touchscreen controller in smartphone, SSD in data center. And also 5G small cell reduced capability, and also general purpose and MPU running Linux. In automotive space, we have a lot of application there, and also recently we have customers adapt our COD processor into to running do a chassis control and also powertrain control. But last but best, in last 2 years, our the largest revenue is coming from large-scale AI and machine learning, close to 40%. So here you can see a bunch of customer logo there. Sorry, this is. This one, can we take out this one? Yes, that's easier. So we need to take.
You can give me a video.
We don't need it,
yes.
Right? Shit.
I will take it.
Oops. Oh, it still works. Okay. Yeah. Hopefully, yeah. It has RISC-V spirit there. Okay, so I want to talk about large-scale AI machine learning. And the popular SoC architecture, we can call it the C of PEs. Basically, you have mesh-connected or multi-cluster base to connect a bunch of processing elements, and where the core of computation is happening there. So like Meta, for example, you mesh-connected. And the role served by Andes processor in a PE is actually multiple. So for some customers, they have all the computation hardware from matrix multiplication to nonlinear operator to even vector processor, either RISC-V or something else, or maybe GPU. They need a powerful scalar processor to keep those expensive hardware busy running. And also, we have the vector processor, which customer can leverage with RISC-V, and then we have like X27V. We probably have a dozen of customers doing that, and the customer can focus on matrix multiplication and so nonlinear operator. And after we have this 45 MPV, a new processor which is vector, but also we offer a custom extension to allow customer adding RVV type of vector instruction to do all the nonlinear operator, which get pretty popular there. And we also know that RISC-V has been working on the matrix extension. So it's possible that, the next generation we're going to cover a scalar vector processor and also matrix multiplication as a standard, while we offer a custom extension instruction capability, so customer to adding all kinds of new nonlinear operator there. So, and even though they don't do, even when custom has all the hardware accelerator out there, so usually they're using our Andes custom extension to do direct control to their hardware unit, so that they will appear instructions, so that AI compiler can directly generate to control them efficiently. So here I want to talk a little bit about our latest vector processor, X46 MPV. It's built on top of the previous generation 45 MPV, which is 8-core, 10, 24 bits VLAN, DLAN, and dual issue vector and scalar. So 46 MPV adding a double gig core count and also the VLAN. And it enhances a couple important RVV instruction, and also enhance the custom extension capability, like I mentioned earlier, so that custom can efficiently design all the new and greatest nonlinear operator to speed up their computation. And certainly the metric multiplication, we have colleagues talk about AMM. So we are working along with the task group, but our customer cannot wait, so we need to do that in parallel. And last, but also very important, is memory bandwidth. As we know, when we go to large language model, memory bandwidth become more and more important. So from the instruction side, we allow dual low, 2 vector, or one vector, one low, one store vector instruction, and also high bandwidth vector memory, where you have a very wide path as wide as the DLAN. And you can have each core, you can have 2 port. And we also designed the HVM controller, so you can have basically very efficient crossbar to access multiple bank of shared data there. And you can have external DMA coming to access that along with the processor data access. Okay, so earlier we talked about high performance controller actually need to be very real time. So right now it's pretty popular. Our customers pick up our X45MP and also 46MP, which is multi-core 64-bit dual issue 8-stage pipeline. It also has single core and 32 version. So what is important about them? So when you have a bunch of hardware controllers there and they are large, right? So you want to keep them busy. So the control and access of those hardware engines is very important. So we have very aggressive multiple outstanding access. In particular, is the write. So you can have multiple write going in parallel. So you can provide a descriptor, for example, for the hardware engine. So once you finish that, and you can immediately start to operate. So there's no this cycle there. And also, if customer want to go one step further, so our ACE instruction allow customer to create a special interface to directly connect to their hardware engine. So there's no limitation of bus width and things like that. And so you can write in as many bits as you want in one cycle. So 5 cents is not, this project is not doing AI, but just show the similar concept. So you can do that. And our ACE instruction support being there for all our Andes core family. And the other thing that's very important is efficient interrupt-driven task dispatch. Because in the AI space, the whole hardware engine basically just keep cranking out data, right? So you got the input and keep cranking it. So as data coming, you send interrupt to the scalar processor, which you need to start to hit the ground and running. So the latency is very important, and also you don't want to jump into the interrupt handler and come back. You want to sit there and waiting for interrupt, and interrupt come, you execute next instruction, you start doing the dispatch work. So our code can cover in that. And so I think in my object we talk about, so earlier we talked about RVV, which is kind of large scale computation, but there's also a bunch of smaller computation which can be benefited by RISC-V RVP extension, which is integer, fixed point, SIMD based on the integer register. So here to quickly show the speed up of CIFAR 10. So it's based on M4, which is also has similar instruction set, from the high level. And based on our RISC-V RV32 instruction, single issue and dual issue, you can see we get 2.9x over M4. Certainly M3, M7 is down there. And if you run that as RV64 and single issue and dual issue, you can get 4x or 4.5x speed up there. So those are processors, but we have also covered kind of software we call AndesAIRE runs everywhere. So we have total solution from the top, take AI model and do the optimization and mapping to our underlying hardware, which is vector processor or DSP processor. And we also have the accelerator we call AndesAIRE, Andes Digital Deep Learning Accelerator. So we're covering for AI compiler, AI interpreter as well. So here's a quick demo. So DeepSeek come out during the Lunar Chinese New Year. So our management team are pretty busy, kind of dig out the internet to find out latest information. And our team, after we finish the long holiday, in 1 week, we kind of ported DeepSeek and porting some of them with RVV optimization. So here's a quick, well, this is recorded, not really a demo because we don't have time. But here I asked DeepSeek to write a 200-word short article about Andes technology, successful deploy the DeepSeek R1 steel model. And then here it start to kind of show its thinking process. I don't have time to show the result, but 300 words is actually better. And we tried experiment to short it to 100 words, it started saying something nonsense. Okay. All right, so I didn't finish that. So Andes has been focusing on AI a lot. So earlier we have a talk about our AMM, and we have a couple other talks related to AI, and one talk for security. So if you had time interesting to Andes AI technology, you can stop by our booth and or come to the our show talk or poster. All right, thank you.